Okay, let's dive into a hidden process that's happening in your brain every single time you read or listen to something. It's kind of like a high-stakes detective story that unfolds in milliseconds, and the craziest part is, you don't even know it's happening.
All right, take a look at this. Just read it to yourself. That the man said anything.
You can feel that, can't you? It's like it's just hanging there. That little bit of tension, that feeling of your brain waiting for the other shoe to drop, for one more word to make it all click. Well, that feeling is exactly what we're going to investigate today.
That suspense you feel, it's actually created by some very special and, you could say, very needy words. So let's take a look at how they work.
So linguists have a fancy name for these words. They call them negative polarity items, or NPIs for short. But really you can just think of them as being grammatically dependent. The moment they show up in a sentence, they create this little question mark that just has to be resolved for the sentence to feel complete.
So how does our brain actually solve the little puzzle that these needy words create? Well, it turns out it does it with incredible speed and just amazing precision.
And this just shows the rule perfectly, right? On the left, you've got sentences like, he did not say anything, or no tourist ever eats raw herring. They just sound, right? But the ones on the right, they feel kind of broken, almost like a glitch in the language, because that crucial partner word, that negative, is totally missing.
Okay, so let's give our needy word its official name, the negative polarity item, or NPI. This is basically the first clue our detective brain spots. It's the word that kicks off the whole mental investigation by creating that unresolved feeling in the sentence.
And every NPI, every one of these needy words, has to have a partner. We call this the licensor. Think of it as the word, like not or no, that gives the NPI permission to be in the sentence. Without the licensor, that tension we felt, it never gets resolved.
And this, right here, is the central mystery. I mean, it's one thing when the licensor comes first, but think back to our very first example, that the man said anything. In that case, the needy word comes before its partner. So how does your brain handle that? Is it just kind of sitting back, passively waiting, or is it doing something way more active, way more clever?
To figure this out, a team of scientists in the Netherlands came up with a really brilliant experiment. Their whole goal was to basically eavesdrop on the brain's electrical activity and catch it in the act of solving this exact puzzle. They used this technique called ERPs. You can basically think of it as putting a super sensitive listening device on someone's scalp to measure the tiny little electrical signals the brain makes. This lets us see the brain's split-second reactions to every single word as it pops up.
So the setup was simple but totally genius. First, they had people read sentences where the needy word showed up before its partner. Second, they cleverly stuck in some extra words to create a delay. And third, they measured brain activity at the exact moment that partner word not finally arrived. But the real key was where they decided to put that delay.
And here's the really brilliant part of this whole experiment. In one version, they added words where a licensor just could not grammatically appear. But in another version, they added a delay right where a licensor could appear. The big question is, does the brain know the difference? Does it only get its hopes up in that grammatically right spot?
And the results were, well, crystal clear. The brain scans showed this telltale signal, a specific brainwave that basically acted like a flare, showing us exactly what the brain was up to during that delay.
So it turns out, only when that partner word was delayed in a spot that was grammatically possible did this specific brainwave spike. This means the brain wasn't just sitting around waiting, it was actively anticipating, and its activity was totally guided by the rules of grammar.
Now, this specific signal has a pretty sciencey name, central anterior negativity. But you can just think of it as the brain's holding signal. It's a direct, measurable sign of the mental effort the brain is putting in to keep that unresolved word, that anything, active in its memory while it's searching.
And this chart, this is the aha moment of the whole study. That searching signal, that central anterior negativity, it spiked highest by a huge margin only when the delay happened in a grammatically possible spot. The brain wasn't just waiting, it was actively expecting. It knew the rules.
And what's even crazier, the longer that delay in the right spot was, the bigger that brain signal got. This is proof that the brain isn't just passively waiting. No, it's actively holding a place in memory, and the longer it has to hold on, the more effort it takes.
So what does all of this tell us about that little detective inside our heads?
Well, it gives us a completely new way of looking at how we understand language.
What it means is that your brain really is a detective. It's not just a passive listener, taking notes as words come in. The moment it sees a clue, our needy word, it launches an active, forward-looking search for its partner, and it uses the rules of grammar to narrow down where that partner could possibly be.
So when you put it all together, the big takeaway is this. Understanding language is not a passive thing at all. It's this dynamic, predictive, and incredibly sophisticated search. Your brain is a grammar expert, running this whole operation in the background, all in the milliseconds between words.
And that kind of leaves us with a final thought. This research opens up this fascinating window, not just into language, but into the predictive nature of the human mind itself. I mean, if your brain is always a few steps ahead when you're just reading a sentence, what else is it predicting about your world right now?